Recording now. Welcome. And to start off with, do you guys have any questions in particular about what we covered this week, or would you guys just kind of like to start from 3.3 and work through some problems in 3.4 and 3.5? It's up to you guys. Okay, yeah. That is definitely something we can work on. Let's do, okay, so we're going to start with some problems in 3.4 then. Actually, let's start with 3.3 just to like get the basics of the chain rule out of the way, and then we'll move on to do some in 3.4. Okay. That's not what I want to do. Okay. So we're starting in section, why is this red? I guess it's not. Okay. Section 3.3, this is page 155. All right. So let's do problem 4. All right. If I give you guys a second, do you guys want to just go ahead and do problem 4 and then come back and tell me what you think the derivative of this is? Awesome. So whenever anyone has a guess, just feel free to put it in the chat. Okay, we can definitely do some of those problems. Rachel, are you looking at problems like problem 40? Yeah, no problem. Okay. So for this, we have one person saying r prime is equal to 4q squared plus 1 to the 3rd times 2q. And that is essentially what I have. So yeah, we're going to quick go over how you got to that answer just to make sure everyone's on the same page. You're close. We have another vote that says 6q squared plus 1 to the 3. And this is close. This is actually an 8. So it's 8q. Because you're going to be multiplying these two, not adding them. So that's not quite right, but this is another way of putting this answer. Okay. How did we get there? Now, I said this last week, and I don't know if you guys took me that seriously or not when I said that I write everything down, but I write everything down. And I start with, okay, so we have this function in the middle, and that's going to be g. So g is going to be q squared plus 1. G prime is going to be 2q. That's a g, not a q. 2q. And then I have f. F is equal to, because these are functions like within functions, I'm just going to call this g to the 4 because this is g and it's to the 4th. And then f prime is equal to 4g cubed. So I know from my equations that they gave in this chapter, that the derivative of f of g is equal to f prime of g times g prime, where f and g are both functions. So I have f prime, I have g, and I have g prime. And so I have all of the pieces I need to put into this to get the answer. So I'm going to say this is f prime of g, so this is 4 times g cubed, and g is q squared plus 1. And then I'm going to multiply this by g prime, which is 2q. And so I can move this to the front if I want to, and just say 2q times 4 is equal to 8q. And so my answer, r prime, is going to be 8q times q squared plus 1 to the 3. And I write all of this out every time I do a problem just to keep track of everything, because I don't want to get confused or miss out on anything. Okay, so we have that. Let's try to do problem 8. So you guys take a sec to try to do problem 8 on your own, and then we will reconvene in a couple minutes to talk about the answer. Okay, so you guys found the answer to be, yeah, that's no problem. Simplifying it just kind of comes with practice. So you have 1/2 s cubed plus 1 to the negative 1/2 times 3s squared, which is right. When it comes to simplifying it, what you're going to do is you're going to put this in the denominator because it's a negative. So you're going to say this is equal to 1/2 or 1 over s cubed plus 1 to the 1/2, and then times 3s squared. So this is going to simplify further into 3s squared over 2 square root of s cubed plus 1. Or you can leave this as to the 1/2, it doesn't matter. But yeah, exactly. So this is like the simplified version. And this is the answer you are going to see on a test. Like if you have a multiple choice test, they're not going to have this. They're going to have something that looks more like this. But it's just kind of like a algebraic like walkthrough of what to do. Okay, so how do we get to this point? Well, we're going to say g is equal to s cubed plus 1. We're going to say g prime is equal to 3s squared. We're going to go and f is equal to g to the 1/2 because it's just the square root, excuse me. So f prime is equal to 1/2 g to the negative 1/2. And so y prime is going to be equal to 1/2 g to the negative 1/2, g being s cubed plus 1 times g prime being 3s. And that gets us to where we were up here. We can follow through to the simplifying steps and get our final answer. Exactly right, guys. All right. So what about number 12? So you guys can go ahead, do it on your own, come back in a couple minutes. Sorry, I was muted. Yes, this is all from 3.3, so it is all the chain rule. So 12 looks like this. Sorry about that. All right, we have one vote that says that y prime is equal to 25e to the 5t plus 1, and that is exactly what I have. How do we get there? Well, we're going to start off and we're going to say that g is equal to 5t plus 1, g prime is equal to 5, f is equal to 5e to the g, f prime is equal to 5e to the g. So we're going to put it all together. We're going to say that y prime is equal to 5e to the 5t plus 1 times 5, or 25e to the 5t plus 1. All right, so do you guys understand how this relates to the rules that we did in the last sections when we were talking about, like, if we have e to the 12t, what the derivative of this is? Based upon the rules in the last section, we would just take this 12 down. and we'd say that the answer is e to the 12t, or 12e to 12t, excuse me. Do you see how this like plays in with the chain rule? How this actually is an example of the chain rule? Awesome. Okay. Perfect. Then I don't have to explain that. Cool. Okay. Let's do problem 18. And we can just kind of do this together. So we have f of x is equal to the natural log of 1 minus e to the negative x. Yes, I am using the rules to do the problem. You say you're getting confused by trying to split it up. What are you trying to split up? What g and what f is? Okay. We can go over like what's going on with that right now. I agree that sometimes it's kind of difficult. What I mostly do is like start. Yes, exactly. F would equal ln x or ln g or something like that, but yeah. So I start with like what's inside parentheses first, because typically what's inside the parentheses is something that is separate. And I say, okay, so I have this chunk. This is like, there's two different ways of doing it, starting from the inside working out, starting from the outside working in. I have this chunk inside the parentheses. This is a function. I'm going to call this function g. And then I'm going to look outside and I'm going to say this is ln of g. And so that's one way to like think about it, is like look in the parentheses, see what the function is, see how it relates, and then look to the outside. Or what you can do is say, okay, so I have this function that I know, the natural log. I know how to find the derivative of ln x. Can I find the derivative of this using that rule? And the answer is no, this is a function inside that I also like need. So like, because it's a function inside that looks like very significantly different from ln x, I would say, okay, so I can find ln x, the derivative of that, and I'm going to be able to find the derivative of whatever is inside here. So I've got two different pieces, so I should use the chain rule. Okay. That being said, you are exactly right in saying that in this case, because f of x is the function and we're trying to find f prime of x, what I would actually do is use h and g. So h being the natural log of g, h prime being 1 over g, g being 1 minus e to the negative x, and g prime being e to the x. Because this is negative times a negative 1, so, and you're going to make this a 0. Okay. Is everybody okay with me using h here instead of f? The rule is the same, the letter is just different. And I always try to make sure it's a different letter, because if this was f, I would find f and then f prime, and then I might think that that is the answer, but it's not. Okay. Okay. So, that being said, I'm going to take a quick sec to rewrite the rule. I'm going to say that this is h prime of g times g prime. And so h prime 1 over g times g prime. So this is going to be equal to e to the x over 1 minus e to the negative x. And that is f prime of x. Okay. Awesome. So that is kind of chain rule stuff. We are also, per request, going to look at problems like 40. And, oh, I think you said 43, right? 43, 45. I've asked you this before. I always forget. You guys don't have homework that you guys turn in, right? Awesome. Okay. Okay. I swear I will remember that next time. Okay, so we're going to do 43 and 45. 43 is asking us to find the derivative of f of g of x when x is equal to 30. And 45 is asking us to find the derivative of g of f of x, excuse me, g of f of x when x is equal to 30. Okay, so we know from our rules that we discussed this chapter that the derivative of f of g of x is equal to f prime g of x times g prime of x, correct? So to start doing 43, we're going to find all of the pieces of this formula. We're going to say g of 30, because x is equal to 30. G of 30, based upon this graph, this is g of 30 is going to be equal to 20, 40, 60. What do you think that is, 55? I'm going to call that about 55. The thing about these graphs is that because you have to estimate, your answers can be a little bit different every time. So I'm going to say that's about 55. It's just under 60. G prime of 30. Well, I've got a line here, so I need to find what the slope of that line is. And so the way that I'm going to just look at it right now is delta y over delta x, where delta y is equal to 20. And delta x is equal to 40. So this is equal to 1/2. And that is the slope of that line. So that's what my g prime is going to be. Because if you remember, the derivative is the slope of the tangent line, and if you have a line, then that's all just one thing. Okay, so then I am also going to look at f. I need, first of all, to find out what f is doing at 30. So I have 20, 40, f of 30 is about 20. And f prime, oh, this is not what I need. This is not what I need. Whoop. What I need to do is, what I'm going to start off by doing is, we don't need to find f prime of 30. That's not what we need to do. I'm going to start putting things into the equation where they need to be. So we have f prime of g of x. We know that g of x is equal to, yes, exactly. So g of x is equal to 55, so we're going to find f prime of 55. Times g prime, which is equal to, g prime of 30, which is equal to 1/2. So f prime of 55, that's 20, 40, 60, 55. This is going to be f, I'm going to do this in pink. F prime of 55 is approximately equal to delta x equal to delta y 20, delta x is 20. This is going to be equal to 1. So this is 1 times 1/2. So the answer to 43 should be 1/2. And I'm going to quick look in the back of the book to make sure that's the case, because it's better to be safe than sorry, and I don't want to give you bad information. So, yep, 1/2. Cool, we're good. Okay, so let's do 45 now. In this case, we're doing the exact same problem, but it's going to be the derivative of g of f of x at x is equal to 30. So we're basically going to do the exact thing but reversed. Because instead of f prime of g times g prime, we're going to do g prime of f times f prime, because f is the one inside the equation. So we're going to start off by saying f of 30 is equal to 20. F prime of 30 is equal to, so delta y is equal to 80, and delta x is equal to 40. So this is going to be 2, negative 2. And because this is negative because it's going down. And then we're going to say, okay, so I need to find g prime of 20 and then multiply that by negative 2. So g prime of 20, the slope of g at 20 is going to be delta y, delta x. Delta y is going to be equal to 20. Delta x is going to be equal to 40. This is going to be 1/2. So this is 1/2 times negative 2. The answer is going to be negative 1. And that goes with the book. So basically what you need to do is, if you're given a problem that looks like this, especially if it's like a graph, just kind of break it down, see what you need, make some estimates. Yeah. Is everybody cool with how to solve these kind of problems? Awesome. Okay. Let's move on to 3.4 then. So this is dealing with the product rule and the quotient rule. And there have been some issues that people have talked about differentiating between when do we use the product rule, the quotient rule, or the chain rule. And basically, my best advice to you guys is to try to use whichever one seems most natural. And if it doesn't work, if you're like forcing it to work, then you're doing something wrong. And eventually, like, you'll get to the point where you're like comfortable enough that, or like you're comfortable enough with the material that you can look at it and your first guess will be right. Just to save yourself some time, you don't need to like deeply analyze every situation, is what I would say. Okay, so number 4, we're on page 160 right now, by the way. Number 4, we have f of x is equal to x e to the x. If I were to start off and say, hey, I'm going to use the chain rule, f prime of g times g prime, I need to find out, or h in this case, h. I need to find out what h is equal to and what g is equal to. So, oh no, oh dear, there's like no function within a function in this like instance, because if I say that g is equal to e to the x and h is equal to x, they're not like within one another, they're multiplied by one another. So in attempting to use the chain rule, or in like attempting to identify the functions within a function, I have revealed that it's not a chain rule problem. It's going to be a product rule problem because you're multiplying them. So in that case, what do we do with the product rule? Well, our product rule states that the derivative of this is going to be h prime g plus hg prime. Again, I need to figure out what h is. H is going to be x in this case, and g is going to be x. Oh, that's a lie. I don't know why I put that like that. That's wrong. Ignore that statement. G is going to be e to the x. So g prime is going to be e to the x, and h prime is going to be 1, because if you take the derivative of x, it's 1. So, had you used the chain rule, if you had not recognized that this was not a chain rule worthy problem, and said that, okay, this is going to be h and this is going to be g, and I'm just going to use this formula, you're going to be off by a little bit. And this is added, not multiplied. So there is a difference, because for chain rule, you need to have a function within a function. Okay. And I think okay, just to clarify, I wrote the chain rule. I keep writing, yes, that's true. It's supposed to be product rule if it's not inside the other function. I keep writing the chain rule like this, or times g prime, but it's really like this. This is a function of a function. My shorthand, if my shorthand confuses you, tell me and I will stop. Okay, now that we have all of the pieces together, why don't we get this started? We have h prime times g, so this is 1 times e to the x plus h x times g prime times e to the x. So the answer to this whole thing is going to be e to the x plus x e to the x. And that's the answer. So this is going to be f prime of x. Okay. Now let's do number 6. So this is going to be y is equal to 5x e to the x squared. Okay, so this is the chapter with the product rule, so we're just going to start using the product rule. We're going to say f is equal to 5x, f prime is equal to 5. Then we're going to say g is equal to e x squared, g prime is equal to, and we hit a roadblock. Because we can't just easily look at this and say, oh, what is the answer to this problem? What we need to do is then use the chain rule to find g prime. So if h is equal to e to the x and k is equal to x squared, h prime or prime is equal to e to the x, and k prime is equal to 2x. So we have, if we're doing this, if we're trying to find the derivative of this, it's going to be h prime of k times k prime, or e to the x squared. This is going to be h to the k, or e to the k. I'm going to change it. Okay, so e to the k. E to the x squared times 2x. So this is going to equal 2x e to the x squared. So now that I've used the chain rule to figure out what the derivative of g is, I can put this all the way up here where it belongs. and then put all of my pieces together and say this is f prime times g plus f times g prime. So to simplify this, it's going to be 5e to the x squared plus 10x squared e to the x squared. Okay. Did you see how that happened? How I used both the product rule and the chain rule. Awesome. What would have happened if I had started off and said, okay, I have this function. I'm going to use the chain rule. I'm going to say that e to the g is going to be f. F prime is going to be e to the g. G is going to be x squared. G prime is going to be 2x. And then I still have an x left over. This rule does not take care of the whole equation, so I can't use just the chain rule to find this derivative. I have a function times another function. So I have to use the chain rule for this one, but the product rule for the both of them together. Okay. So why don't we try let's do number 12. So let's start off, let's do this like piece by piece together. This problem looks like P is equal to T squared ln T. Okay, what is F going to be equal to? First of all, do we think this is going to be the chain rule or the product rule? Product rule, right. Okay. Which of these functions are we going to say is F? All right, T squared it is. And which of these is going to be G? It's going to be ln of T. Okay, so F prime is equal to 2T, and G prime is equal to 1 over T. So we're going to put these all together. We're going to say that P prime is equal to F prime G plus G prime F. This is going to be 2T times natural log T plus 1 over T times T squared. And this is just T squared over 1. So to simplify it, we're going to say this is 2T natural log T plus T squared over T. And what we can do is divide out by 1T. So the answer is 2T ln T plus T, because T squared divided by T is just T. Okay. And this is going to be P, or dP dt, depending on what notation you want to use. Okay. Let's try... Let's try 22. So all of what I said about the product rule applies to the quotient rule as well. And differentiating between the product rule and the chain rule, product rule, or the quotient rule and the chain rule. And it's going to be fairly obvious when you have a quotient rule problem, because there's going to be division involved. Okay. So we have this problem that looks like f of x is equal to x over e to the x we're going to start by saying h is equal to x, h prime is equal to 1. And then we're going to say that g is equal to e to the x, g prime is equal to e to the x. What does this formula look like? Well, it looks like f prime g minus f g prime over g squared. Okay. So, or in this case, this is going to be h and h. So this is 1 times g, which is e to the x, minus x times g prime, also e to the x, all over e to the x squared. Okay. To simplify that, that's just going to be e to the x minus x e to the x. Yep, that's exactly it. It's not a dumb question at all. When you just have x and you're taking a derivative, it equals 1. X prime equals 1. And the reason that is if you have like x squared, it's going to be 2x because you take whatever's up here and then like put it down. And so what this really is it's 1x to the 1, and you're going to take the derivative of that, and that's going to be 1x to the 0, and anything to the 0 is equal to 1. So it's really just 1 times 1. So it's like the same rule. Okay. Yep, so just to finish this off, and this is going to be cool. Okay, so there's that answer. Let's do a different quotient rule problem, maybe one that's a little bit trickier. Let's do 28. And let's do it together. Okay, give me just 1 second. Okay. Okay, so what is going to be f and what is going to be g? Usually the one in the top is f, just to make it easy. So we're going to say that f is equal to 1 plus z. F prime, in that case, is equal to 0 plus 1, or 1 prime. Then we're going to do g is equal to ln x. G prime is equal to 1 over x. We are going to write this in the corner just to remind ourselves. And then we're going to put this all together and say this is 1 times ln x minus 1 plus z times 1 over x. Oh, why did I do this as x? This is z. This is z. I'm sorry, this is z. All of this is z. The variable we're using is z. So this is 1 over z. And all of this is going to be over the natural log of z squared. So we're just going to simplify this down, and we're going to say ln z minus 1 plus z over z over ln z. squared. And you can do some algebra to like rework this and like put it in maybe a nicer form-ish, but it's really not going to get much nicer than this. And a lot of the times if you have a quotient rule and it turns out that like you can't really simplify what's in the bottom and you can't really cancel out with stuff on the top, it's fine. This is what the answer to a lot of quotient rule problems looks like. Just feel fine, like become comfortable with the fact that you can put fractions just like that. Just like leave them there if you want to. Doesn't really matter. Okay. Okay. So let's do you guys have any questions about the product rule, quotient rule, how to differentiate between those and the chain rule? Any questions about that so far? I'm seeing nothing. Okay. I guess that's good. Can you guys just like rank in the chat box like 1 to 10, 1 being like what's going on, 10 being like okay, I can do this. Like how you feel about this material? Awesome. Awesome. Cool. Okay. We are going to move on and we are going to do some problems from 3.5. Why 3.5? Because yeah, this week is a little harder than last week. This week is kind of sorting out all of the things that make things messy. So we're going to do some problems from section 3.5 because remember last week when we were talking about like how we couldn't do all of the problems here because we didn't have access to the chain rule, product rule sort of things? Well, now we do. So we are going to do a variety of problems. And the trick will be to figure out what rules to use and what ones to not use. And that is our goal for doing these problems. So we are going to do, this is going to be, oops, give me a sec. This is page 164. Please stop that. I keep pulling it down. I shouldn't write this high up. 64. We're going to do number 10. Which is W is equal to 4 cos t squared. We are going to do number 12, which is Y is equal to sine x squared. 14. Actually, no, we're not going to do 14. We're going to do 16. Let's do 20. Okay. To start with. And then let's also toss in let's toss in 14. I lied. We're going to do 14 too. Okay. First off, we're going to go through and identify what rules we should use with these problems. Starting with 10. What rule do you guys think we should use? Chain rule. I would agree. What about 12? Also chain. 16? Product rule. 20? not quite. We have a division bar here, which is pretty, yeah. It kind of just is, oh yeah, sorry. So this is going to be quotient. I don't know if that's spelled correctly. And then what about 14? We have 1 vote for product. Does everybody agree with 14 being product rule? Does everybody agree with this? Chain, we have a vote for chain. We have another vote for chain. Chain is correct. It also includes stuff that we did last week. Because all there is a number in here, so we're just going to spit that number out, which is technically the chain rule, but is also something that you kind of learned as a rule on its own last week. Okay, so we've established all of that. Let's go ahead and find some of these answers. You guys did really well identifying what you're going to use for these. Okay. For this one, F is going to equal yes. And just we had somebody in the chat box just write for cos, which, like, I understand what you're trying to say, but it's always the cos of something. So there's always got to be, like, even if you're like trying to type something generic, you're going to say cos x or sine x, because cos on its own doesn't tell you anything. And I'm not trying to be like super hypercritical of you guys, but last semester I had a student who like thought that like just like for like half the semester, because I just never corrected them, thought that like cos on its own meant something, but there always has to be some form of like number or variable afterward. And I just want to make sure you guys are clear on that. So in order to be absolutely clear, cos x is what you want to write, or cos g. But you're correct. And so what we're going to do is find f prime, which is going to equal, based upon our periodic rules from last week, it's going to be, yeah, it's going to be negative 4 sine x. Yep, exactly. You got it. And then g is going to be t squared, and g prime is going to be 2t, or this is g. Yep. So we're going to put this all together, and we're going to say that w prime is equal to f prime of g, so negative 4 sine t squared times 2t. And we can simplify that to negative 8t sine t squared if we want to, but for right now, just like space-wise, I don't think we should. So there we go. Let's try number 12. What is f? F is going to be sine g. F prime is equal to cos g. Is this negative cos g or is this cos g? Yes, positive. Exactly on top of things. All right, g is equal to x squared. G prime is equal to 2x. We're going to put it all together, and we're going to say that y prime is equal to cos x squared times 2x. Okay. All right. So here we decided that this was going to be the product rule. So we need to find f and g. So f is going to be x squared and g is going to be cos x. And I just do that by like whatever one comes first. F prime is going to be 2x. G prime is going to be positive or negative sine x? Negative, exactly. Okay. And then we're just going to smoosh it all together, and we're going to say that f prime of x, sorry, I use the same variables, this can be h, is going to be equal to 2x cos x plus x squared negative, so this can be minus x squared sine x. Okay. And continuing, f is equal to t squared. Here it is important, or h, that you get which one is on top and which one is on bottom when you're doing this order. This is cos t. H prime is equal to 2t. G prime is equal to negative sine t. Yep. And I'm going to write the derivative over here so that I have room. It is going to be 2t cos t minus t squared negative sine t, so plus sine t squared sine t all over cos squared t. And so this is just like a general way of like writing a periodic function with an exponent. You can put the exponent right after the letters and then have the variable right after that. So that's why this works. Okay. So our last one, what is the derivative of this? We said we were going to use the chain rule. We can certainly use the chain rule. We also have what we had going on last week. Let's say that f is equal to cos g, f prime is equal to negative sine g, g is equal to 4 theta, and g prime is equal to 4. So z prime is going to be equal to negative sine 4 theta times 4, or negative 4 sine 4 theta. Okay. You guys did really well this week, like very well. Basically what I would recommend when it comes to doing these problems is to practice, and try to like make a guess before you like attempt the problem. Like say, I think this problem is going to be the chain rule, and then like see if it is the chain rule, see if you can solve it using the chain rule. If you can't, then say maybe it's the product rule, and like try to use each rule, but like try to look at the problem beforehand and make a guess so that you can like practice like identifying like what rules are used when beforehand. Are there any other questions regarding this content? Basically what this is a lot of memorization. You're going to do enough of these problems hopefully that you like know these rules like the back of your hand, and kind of just can like do them whenever, but you do have to like, these rules are like integral to like what's going on in this chapter, so you have to be able to, yeah, flashcards do help. You just kind of have to be able to track what's going on. So yeah. If you guys come up with any questions during the week about last week's stuff, anything before this, whatever you're working on next week, just feel free to email me if you need help with anything. And have a great week.